Everyone, I hope nobody left. It's 10 minutes to 8, and my main goal is to keep you awake. So my name is Andreas Kokotos. I'm a partner of Argonavis Marine Consulting and Engineering, and in affiliation with United Naval Architects and NAV Marine, we're offering consulting services for the ballast water treatment projects. So our today's presentation has to deal with engineering challenges of ballast water treatment systems retrofit. So the contents of our presentation are, first part, pre-selection of a ballast water treatment system. Second part, engineering challenges. Third part, conclusions and suggestions. Now, everybody is asking us, come on, you deal with ballast water treatment systems for more than 4 years. Tell us, which is the best ballast water treatment system? Sorry to my friends here, the answer to the question, does the best ballast water treatment system exist, is no. There is no best ballast water treatment system. All systems have advantages and disadvantages. Another question is selection of a ballast water treatment system an easy process? The answer is quite easy, no. Actually, why we talk about pre-selection and not selection of a ballast water treatment system? Imagine that we have selected the worldwide type-approved system, which is built by a reputable vendor. It's #1 in sales, and we've got it free of charge. Are we sure that we can fit on board our vessel, and at which cost? That's why we have to pre-select some systems and then investigate if it's feasible to install on our specific ship. Why pre-selection of a ballast water treatment system is a complicated process? Because we have to assess many different parameters in order to shortlist the ballast water treatment system that match the requirements of a vessel's owner or operator. I will give you some tables. It's difficult to remember everything, but we can further discuss. Which are these parameters? Ship and service characteristics like ship type and capacity, ballast water handling practices, for example, Framo pumps, ballast water characteristics like salinity, turbidity, as we discussed, vessel trading characteristics, are we doing voyages inside rivers, for example, and ballast system characteristics, what is the type of the pump, the capacity, the head, how many pumps we have, etc. Now we have the treatment technology factors. We have different treatment methods, different treatment system pressure drops, different equipment size and space requirements, different materials, approval for installation in hazardous spaces, power requirements, impacts on ballast tank and pipe corrosion, health and safety in respect of handling and operation. And we have more parameters. We have a general considerations, which include proven efficacy and type approvals, vendor qualification and reputation, maintenance requirements and system reliability, simple operation, control and monitoring, life cycle costs, service and availability of spare and replacement parts. These are some of the parameters we consider the most important ones that we have to take into consideration when we are talking about selection of a ballast water treatment system. Don't forget, there are more than 100 different ballast water treatment system makers to be assessed. We met at least 20 new makers in the last SMM exhibition, and a lot of people are saying, I don't care about all of them, I care about 10, 20 most reputable ones. The question is that if they have time to deal with you, because they are not able, the 10 or 20, to build and produce systems for all ships. So we have to assess as many as possible. Don't forget, you don't buy another equipment, you buy regulatory compliance. You are going to be controlled by port state controls at every single port for the proper operation of your system. So it has not only to do with the operation of your ship, it's a regulatory compliance. Don't forget, there is going to be a bottleneck on availability of systems, on availability of shipyards, on class approval. Don't forget, you have to start your preparation as soon as possible. We have performed many techno-economic studies in order to support the client's effort for proper information. We have reviewed information and prepared technical and commercial evaluation of more than 35 different ballast water treatment systems for more than 25 different ship designs, which includes the following. We assess the technology and the status of approvals, treatment process description, system testing, and regulatory review and certification. Unfortunately, this is an ongoing process because we have just started the US Coast Guard type approval process, and soon we're going to have new type approvals based on the revised IMO G8 requirements. We describe the system specification, vessel types which the system is expected to serve. There are systems that you cannot install on tankers. Systems characteristics like capacity, power, unit dimensions, unit weight related to capacity. We try to give replies to various operational issues. For example, when do we treat ballast water? During ballasting, during deballasting? What's the filters cleaning process and what's the flow reduction? We have heard, and also the gentleman here has spoken about frequency of backflashing. In some dirty rivers, it's quite often to have backflashing, sometimes every 2 minutes. Efficacy affected by ballast water characteristics. This is a big issue here, mainly with salinity and secondary with the dirty water as described by the gentleman from PANASIA. Maintenance requirement. This is unfortunately for us a gray area because we have to believe each manufacturer regarding the maintenance requirement of its own system. We have received from 2 different makers different maintenance requirements for the same type of filter, actually for the same manufacturer of filter. So here we need to spend some more time. Operational complexity, we will discuss later about this. Health and safety issues. We are putting, in some of our systems, we are using chemicals, we are producing chemicals on board, we are using gases, we are producing gases, etc. We have to take care about how we handle them and how its installation is safe. Coatings protection and effect, again, is another gray area because we don't have feedback from operation. Other in-service requirements, there are too many, believe us, and controls and alarms. And the most interesting part for most of you is the commercial issues, So we check the purchase costs for various flow rates and tank capacities. We evaluate the service network, operating and maintenance costs for various flow rates and capacities. We are doing our own calculations based on data that is provided by the ship owner. Delivery time for supply, a first approach to the complexity of installation based on received drawings, and also we assess the vendor's experience, because as I said before, we have more than 100 makers. We finished the first part of the pre-selection process, and now we go to engineering challenges. And after pre-selection, what? This is a major question. Believe me, it's more difficult. A survey on board has to be performed in order availability of spaces and other in-service requirements to be assessed. Somebody has to go on board and check the vessel. You've heard from the PANASIA gentlemen, and most probably from other guys, that we are performing, or they are performing, a 3D laser scanning when they go on board. Why? Why do we have to perform a 3D laser scanning? Now, there are many reasons. The basic one is that it is possible to see how the system will fit on board our ship before any further actions taken, and to compare different options in case the owner has shortlisted more than one ballast water treatment systems. This means that we have your ship in our computers, and we are trying to install your equipment, your pre-selected equipment or equipments on board the ship before you purchase it. So you can check various options, various difficulties, various modifications required, and to see the feasibility of installation before you pay the money. Now, the 3D laser scanning is a relatively fast process, depending on the type of the vessel, and does not interrupt vessel's normal operation, and also it eliminates most of the risk associated with manual measurement. We need too much time to have a very good view of the vessel without the 3D laser scanning, and I suppose we cannot have all the details. So that's why we are performing 3D laser scanning. We have performed so far 30 surveys on board and 3D LS, 3D laser scanning surveys. These are some of the vessels we have performed for many different types of ships, mainly tankers, general cargo, bulk carriers, tankers with Framo pumps. We have performed feasibility studies for more than 15 ships, assessing the retrofit installation of 12 different ballast water treatment systems. This was the pre-selection of the owner. This is PANASIA, for example, and other different makers and different technologies used. The most interesting part, we have performed one class-approved engineering study and 3 outline installation specifications for the retrofit of ballast water treatment systems. And this is very interesting. This is the drawing of the first installation, and these are some drawings for the preliminary specification. The first study that we have done is the number 5 retrofit of a ballast water treatment system approved by GL worldwide, which means that there are no retrofits. And we have to remember that when assessing further the engineering challenges. The outline installation specifications are not complete studies and definitely are not class approved, but is a very good idea for a company to have requests from shipyards in respect of the cost of the retrofitting installation based on our study and our drawings. So for a budgetary purpose, it's a very convenient tool for the ship owner. These are our clients, mainly Greek and companies located in Cyprus and in the Baltic countries. Let's go now to the main item that we have to discuss tonight. Engineering challenges, and number one is the class approval of the installation. This is only the first page. Classification societies are very preservative in respect of approval of the retrofitting installation of a ballast water treatment system. And they ask too many things, too many details, sometimes overreacting. There are too many reasons. The basic ones are they don't have experience with the retrofit of such an equipment on board the ship. Another thing is that we're talking about a complicated issue where too many different departments inside the classification society are dealing with the approval. And the third and unfortunate thing is that they don't have people with experience to do the job. Luckily for us, in Greece, there are quite a lot of experienced people in respect of ballast water treatment system, but there are not too many. Now let's talk about footprint. You hear about footprints, all the makers are talking about footprints. So this is a bulk carrier. It's the first survey on board we've done 1.5 years ago. When we entered on board, we said, plenty of space. You can see the ballast pump, and in front of the ballast pumps, plenty of space. So we have modeled the space. These are the pumps, and the modification of the pipes is just to put upside down these elbows. So this is a basic equipment, filter and UV. Observation number one, you can see some pink boxes. These pink boxes, which is very difficult to understand, is the required maintenance or service space from each maker for each different equipment, which means I have found space to install my filter, but it's not possible to open when it's clogged. So obviously this location is not the correct one. So we have to take care about the maintenance space. And the maintenance space usually is not included in the provided footprint by the makers. But in any case, you can see that still we have plenty of space. What do we miss? The pipes. Let's see the pipes. These are the minimum pipes required for the system to operate. We have not exaggerated. We have tried to put as few pipes as possible and few lengths, but we have many challenges because, as you can see, the installation is not symmetrical because below we have valves, we have openings for access, we have equipment that we have to monitor, etc. So you can see that a relatively easy installation from the first approach and the first point of view, it's not so easy because, for example, we cannot access now from the port side of the engine room to the starboard side of the engine room. So the footprint is a good indication, but it doesn't mean if I have a space equal with the footprint of the equipment, I can fit it on board my ship. Another engineering challenge is the pipe routing. I found a location, a very nice location, where I have to install my system. How do I connect with the existing piping system? Now you will see a video with one filter for the after-peak treatment. It's one of the most simple installations. So we have, this is our main engine, and this is the location of the filter. And now we have to connect, simply two connections, one supply and one return line. We have to go below the floor covers, floorings. We have to find the pipe, we have to connect, we have to bypass, and we have to return. And of course, there are many pipes in between. So our goal is not to remove any single pipe, if possible, and to find the proper pipe routing. So this is something that we can do only with the use of the 3D laser scanning, or if we spend some days on board when the system is in final location. Another engineering challenge is the supporting. In our first installation, we had only one filter for a general cargo ship, but it was absolutely impossible to support it on the floor because we had too many pipes below, and we had to remove them and to modify them in order to do a proper supporting. So what we've done, we hung it from the ceiling. So this is the scan result of the engine room, and this is the model of the filter with the support. We have to do only a small modification on the air duct, obviously, and some small modifications on pipes at the ceiling. But it's not so simple as it seems. We have to model, and then, because for this system, 1,000 cubic meter system, the wet weight of the filter is about 7 tons, we have to calculate the forces, because we don't want the filter to go down, to fall down, either to some personnel, some crew, or to the equipment below. So we spent significantly many working hours with special software tools in order to assess this simple supporting, which is class approved. Another big issue, pressure drop. By the way, this is a PANASIA study, system study we have done for a chemical tanker. With the white, you can see the existing pipes. The rest is the new equipment. We have calculated that the pressure drop is about 1 bar. So we have existing pumps with a suction head of 2.5 bars. And now we lose another 1 bar because we put something new at the discharge of each pump. Most probably we have to replace the pumps or to upgrade the pumps because it might be not sufficient for proper ballasting and deballasting operations. And this has nothing to do with the selection of the system. This is typical for most of the system that are going to be selected. So pressure drop is a very big issue, and we have to carefully calculate this. Another big issue is the flow meter. Every system has a flow meter. It's a very significant equipment for proper operation of the system. But there are some requirements for its installation. The flow meter has to be always full of water, and we have to avoid any turbidity. So there are some certain requirements in respect of the length before and aft of the flow meter, and the location, if it is close to bends, if it looks, the direction is upwards or downwards, etc. We didn't think that this is going to be a big issue, but in practice, it is one of the biggest issues we are facing during the retrofit installations. We have discussed with the PANASIA gentlemen here. They are using some new flow meters with some improved requirements we have to further assess. Now this is a very hot issue. Electrical installations in hazardous areas. As you can see, this is an ABS, additional requirements for the placement of electrical equipment in hazardous areas, issued 1st of August 2014, and it's in red. Of course, it's red because it's something new, but also it's in red because we have to be very careful. Installation in hazardous areas is a big nightmare. Still, some requirements are rather extreme, according to us, but these are the class requirements and we have to further discuss. So the installation on board the tanker is a relatively more difficult issue than the installation on a bulk carrier or a container. Now, another issue that we have to take care of. We found location, we found the perfect position to install our equipment. The question is how we put it, how we transport it to this location. Sometimes we have to cut the side of the ship or to open, to make new openings in order to transport the equipment on the final location. We've given some examples. This is a pump room of a tanker, and this is a filter. As you can see, it doesn't pass through the existing opening. So we have to increase the opening. So we have some additional thoughts and considerations when we do survey on board. We have to take care if it's possible to transport the equipment in the finally selected location. The level of automation. The last months we had some good experience with a new building being built in Japan, where most of the valves, all the valves, are manually operated. The question is, if I have a valve in a wrong position, I may send chemicals overboard, or I may bypass the system without knowing that. So we need a level of automation. This is a logic of PANASIA. It's not so complicated as it seems. It can be more complicated. The major question is, who is responsible for what? Most of the makers, they are able to do everything automatically. To press a button, if all valves are in proper location and proper position, we start. If not, we don't start. But this is the fully automatic mode. Unfortunately, most of the shipyards, they select to have a semi-automatic mode where the personnel, the crew of the ship, has to confirm that the valves are in correct position. If we confirm that the valve is in correct position and it's not, then we can have some incidents. So we have to be very careful in the level of automation we select for our installation. We have more engineering challenges, which are other in-service requirements. Cooling water. Many systems require cooling water because there is developed heat. So we need fresh water from our system. They need compressed air. Some of them, we have to wash them. Some of them, we have to drain them. Some of them, we have to heat them because they need a certain temperature of seawater in order to perform their operation. and definitely most of them we have to proper ventilate them. So you can see it's not so easy. Another big issue is the interface with the existing equipment. So, let's go to some conclusions. Let's see where we start. We start from our techno-economic study. We can do it in-house, we can do it with a consultant, and then we have to do a pre-selection of systems, and then we have to do a 3D survey on board and a 3D laser scanning. How much time we need for this? 6 weeks for the first 2 parts, 1 week for the third part. Now, when we come back to the office, we have to do a feasibility study for the installation of the pre-selected systems. And then we have to finally select the system in order to start our engineering study. We have to point out that in this point, the delivery time starts counting for the equipment. Today, with no request, no sales, all the makers need 4 to 6 months. We consider that this figure is going to be improved, but not dramatically. So from this point, in order to have our system, our selected system, X works, we need 4 to 6 months. For our job, we need for the feasibility study 6 weeks. For the selection of the equipment and the contract signing, the owner needs 2 weeks. And for the engineering study, we need 12 weeks. Let's go to the difficult part now. We have completed a study which has to be approved by class, by flag administration, by the owner, and by the maker. This is our prerequisite, our study to be approved by the maker, not the maker to come at a later stage and ask for additionals. The duration for the class approval is unknown. We have experience with 1 class approval. We have submitted drawings in June, and we received our first comments in September. Now, without a congestion, without bottleneck. After that, we have to prepare a specification of the retrofitting in order us or the owner to evaluate the offers, and then to select the repair facility and to be ready for the installation. We need additional 2 weeks. So in total, we need 29 weeks from the beginning. So we need something like 7 months plus, without taking into consideration the class approval. So the major conclusion is that ballast water treatment retrofit is a complicated project. Here you will see a video for a study we have done for the installation of PANASIA equipment on board the tanker. It seems easy, but it took us almost 1 month to finalize this. This is a relatively small ballast water pump room. Actually, no space at the first floor, first level, first deck. And then we have to go to the second deck, where it's relatively bigger space, but we have the opening for access, for SOLAS, and then we need maintenance space, and we need lengths for the flow meters, etc., etc., etc. So our goal is not to do many modification on the existing equipment and existing structure, which is going to increase the cost. So we have only one suggestion, that you have to start now your preparations. Thank you. Now, I don't know if you have questions to me or to the gentleman, so you can ask freely. Yes.
Yeah, just okay. The answer is that like that. So for the new ship, so we normally connect the fresh water or drain. So when you just drain out, we so flushing with the fresh water that to remove the salinity inside of the filter. So yes, just for preventing of that. This is special cases. So normally, so just drain the seawater, and after we haven't experienced any salinity inside of the filters. So if have got this kind of problem, we just alternative solution is that the connecting fresh water, the flushing the clean water, so the all the salinity just comes out. Thank you.
Yes.
I'd like to ask one question. Why do you need a flow meter? I thought this is a flow-through system. Why do you need a flow meter? You have it in your drawings, you have it as option. Do you really need a flow meter in your system?
Normally, the flow meter is the included, not the option. So I'm just wondering, so would you just give us our proposal that the flow meter is the option? So normally, okay. So after the seminar, I will have a look at that. So flow meter that's necessary for.
What is the purpose of the flow meter since it's a flow-through system and it goes to a ballast tank and you can measure the capacity in the ballast tank? Why do you need a flow meter?
The main reason we have the flow meter is that UV guarantee. UV guarantee you can control the flow, and we can control the intensity of the UV.
Another question I have is about U.S. Coast Guard regulations. You state that you change the DNA of the microbiological, but you don't kill them. I understand that the Coast Guard is going want kill dead.
At the moment, the U.S. Coast Guard, the standard is pretty much same as IMO regulations at the phase one. But phase two, you say you're right, it kill them all. But at the moment, U.S. Coast Guard, they didn't have any, protocol has been not been decided. In the meantime, the phase one, in order to get the U.S. type approval, we need to comply with the phase one, not phase two. Phase two,
When you get phase
we are prepared to comply with phase 2. We actually self-tested, and if we control the flow, so we kill all the bacteria, and we can comply with the phase 2 as well. Yeah, just for tips, we control the flow. Just the flow little slow going through that our filter, having got more UV wave inside and just fully kill. There's the timing, the timing of the ballast, that we need to check out, but we just for a test to kill the bacteria. So I'm not sure how fast we can do the ballast, but when we test just for the kill to comply with the phase 2, so we test it and it works to comply with phase 2 of the USCG regulations.
If you don't kill all the microorganisms and you put them in your ballast tank, you arrive at the port where it's going to be tested. The testing method is when in your ballast tank, or the material you have in the ballast tank, which will have some weaker, because as you say, when you pump out, you pass through UV again, kill again.
Now,
How are you going to pass the testing?
the testing, when we ballast, we need to comply with the regulations. So nothing related with the deballasting, 2 times. So just for one time treated, we need to comply with the regulations. Yes.
Just a small clarification. We take samples from the overboard pipe. We don't take samples from the ballast tanks. So the testing is at the sample point, which according to IMO has to be very, very close to the overboard valve. So actually we test the water, the ballast water that is coming out of the vessel. Now for the systems that they have they use UV technology and some other systems as well, but mainly for the UV, we're doing treatment during ballasting and deballasting, and after that we take the sample. So the sampling is at the overboard valve, not inside the tanks.
Yeah, just one additional answer to your question, that another alternative solution to comply with the phase 2, we have 2 type of UV chamber. The one is original, and second is the mega UV. That's the much stronger than the original one. So we save the power consumption when we save space. That's the new generation of our UV chamber. So the mega UV, when we test the mega UV, we can comply with even phase 2 regulations. Okay, thank you. Yes, right.
Yes?
Without any reducing of flow, so mega UV can comply with phase 2, even phase 2 regulations.
The electricity consumption will go sky high.
No, as I told you, our mega UV system is more capacity, less power consumption. It's on our brochure. We just have a look at the brochures. If you need details, so we will send you our tables of our product line. Thank you.
One more question.
Okay, in my presentation, I already told you Because of the two treatment, it's about the IMO rule. They mentioned UV unit type should have tested as two treatment system. Following our self-test, there is no problem of one treatment. Yes.
Uh,
Yes, we know, but yes, if the IMO rule is changed, we will follow that. But now rule mentioned that UV type should be treated 2 times. That's why we followed.
Just, excuse me, I want to make a comment on your question. There is the problem with the filtration. When we are doing treatment during deballasting only, we have to do filtration, which means because so to do only filtration during ballasting and UV during the ballasting treatment. This is another issue again.
Okay, unfortunately, now for this kind of conception, we cannot guarantee because all systems should follow the rules. So if you, how can I say, if you're, how can I say, the good, okay.
This is a matter of rules. It's not a matter of the capacity of the equipment. The equipment can disinfect. Excuse me. The equipment can disinfect, but it's set up in a way in order to comply with the rules. And that's what we have to do at the moment. The equipment is capable of doing disinfection only during the ballasting, according to our tests, but we're not allowed to do that at the moment. When we are allowed to do that?
You know, so we've got this kind of question very beginning of that, you know, our system. We deliver 440. So whenever we deliver the, you know, our system, you know, ship owner, they don't wanna, you know, to operate our system. That's an additional, you know, cost for that. So, but the rules is the rules. You know, performance is okay. So whenever we ballast it, so we get a sample, we test it, it's okay, comply with the regulation. We kill. And when it deballasting, also we get a sample, it comply with the, you know, water emission regulations. So performance, you know, we can, you know, our system is that comply with that the regulations, both ballast and deballasting. But you know that rules is rules. If you don't, you know, that you don't turn on our UV lamp when you do the deballasting, it's, you know, it's out of the rules. So.
Any other question?
Okay,
Let's wait.
just to add something. For example, Thanamaris, since they have installed a lot of PANASIA systems, they wanted to test by themselves that what they have been approved and what they are selling is the correct one. So what they have done, and they have done it numerous times, and they have confirmed to us, is that they did chemical analysis on the sample when they did the ballasting and the deballasting, and they gave it to independent laboratory, and all the results were satisfied. So, but you know, the thing is that as a maker, they cannot tell you that you can make treatment one time only, because they are approved to make 2 times. Yes. Officially, you will have to make two-time treatment, but unofficially, if you will take a sample during balancing, yeah, because it is exactly. Uh, Let me tell you something. When they did this job, when they went to IMO, 5, 6 years ago, it was compulsory for them at that time to make two-time. So all the certifications, all the procedures, all the tests that they have done for the classification societies and the IMO, because they get final approvals from everyone, it is with two tests. So if now they want to change something and they have to move on one-way treatment, maybe they will need a couple of years, 3 years, and I don't know how many millions of dollars to invest to be recertified. So now everything will be done with, you see also that a lot of electrolysis system, now they turn to balancing and debalancing treatment. So let's see how this will move on, okay? It was for the ballast tanks, cargo tanks, fuel tanks. Okay, okay.
Was that done using the ship's computer or?
All right. I think that that correctly, the best way, the portable level gauge system, just wiring things, and you can correctly measure how much it is. So normally that electro type of that gauge system, it needs to be correctly calibrated. So you mean that's the 95%. If you calibration wrong, it can be 40, only measured 40%, but calibration should be done properly. So if you're not sure that calibration, you can double check with that portable level gauge system. Yes. Okay, so I will check this out. So I will send you email through to you. Yes, through the PPCO, I'll reply back to you. Okay.
One more question.
Thanks for your
Yes.
question.
Well, our experience from new building projects is that when they include the ballast water treatment system in the new piping arrangement, the ballast piping arrangement, they are doing the calculations, they are calculating the total pressure drop, and then they select the pump. So theoretically, the pump's head is a little bit increased. Instead of 2.5 bars, it's 3 or 3.5 bars, depending on the system. But for a new building, it's rather easy because the other way around. First, we calculate the pressure drop on the piping, ballast piping system, including the ballast water treatment system, which with its maximum pressure drop, and then we select the pump. Usually, the pumps are of the same capacity, but increased head, usually. But not for all systems, depends on the system. This is my experience.
I mean, we're going to check which hull number it is, and then I can let you know. Okay, so, yeah, we will check carefully. Yeah.
So normally, our maximum pressure drop is 0.67. So as you said, this is our pressure drop, our system pressure drop, and also should be calculated the pressure drops on the pipes and other things. So as he said that normally realistically it can be increased of the capacity of the pumps. It is answer to your question.
Any other questions? From my side, thank you.
Okay, I would like to thank all of you for being here today. Messrs. PANASIA, Messrs. Argonavis, and all of you for being here. Thank you very much. Thanks a lot.